In this video, we're going to talk about the candidates test to find absolute extrema. So we just learned about absolute maximums and absolute minimums from a graph, but now we're going to do it algebraically. All right, so a couple of quick things. All right, critical points are important for absolute extrema. So if I look at this graph, my absolute min happens at the bottom of a valley. That's a critical point. And it happens, absolute max happens at the top of that hill. That's also a critical point. So critical points are going to be important for finding absolute max and mins because that's one place they can occur. All right, what about the other place they can occur? Well, here's a place where my derivative does not exist. That's an absolute max. Again, it's still a critical point. Remember, there's two parts to the critical point definition. There's derivative 0 or it does not exist. But also there's this point here. Right, that's my absolute min, and that's nothing interesting in terms of the derivative. My derivative is kind of going down that direction, but it is important in terms of the picture. It's the end point of my picture. All right, so that's the other place an absolute max or min can happen. You kind of cut off your graph right at the end, and that ends up being the lowest or highest point. All right, so to summarize that, there's two places my absolute max and mins can happen. They can happen at critical points, and there's actually two definitions for that. Or they can happen at the endpoints of an interval. So just remember, I keep in mind all those different possibilities, technically like three possibilities: my derivative 0, my derivative does not exist, or the endpoints of the interval. All those are possible places my absolute max and min can happen. All right, so we're going to determine the absolute extrema for this function on the given interval. A lot of times you're given an interval. Because you're not given an interval, it just kind of goes off to infinity and it's not very interesting. All right, so first, this is called the candidates test, because I want to find all the possible candidates where my absolute maximum can happen. So I can already start my list of candidates. I already have -1 and 3. All right, the endpoints are always candidates because, again, you can get that situation where it kind of starts at the lowest point and just kind of does something. All right, and that would be your absolute min or absolute max. All right, but the other ones happen at my critical points. And to find critical points, I need to find my derivative. Critical points happen at two different places where my derivative is 0 or it's undefined. Here I have a polynomial, so it's never undefined. So I just need to figure out when this is equal to 0. So these are two more candidates for where my absolute max or min can happen because they can also happen at critical points. So 4 and 1. But actually I can take away one of these. I don't care about 4 being a candidate because it's not in the place that I care about. It might be a high value for my function, but it's after the point I care about. All right, so I have 3 possible candidates for where my function could have a max or min. Now, how do I figure out which one's which? Well, I'm trying to find out the absolute max and min for my original function. So I'm going to take all of these values and plug them into the original function. Because I want to know, if I look at that graph of the original, where's the highest point, where's the lowest point? Those are coming from the original. Right? So I use the derivative to find that critical points, but I'm plugging these values into the original. So the first thing I'm going to do is plug in -1. It's going to be -1/3 minus 5/2 minus 4. And let's just make it go a little bit quicker. We'll use a calculator. And it turns out it's not super fast to type in, so let's stay together for a second and type this in. All right, so I'm now putting in -1. I get -6 point. Oh, let's make it a fraction. -41/6. All right, next is f of 3. That's going to plug in 3 into my function. I have it typed out, so now it's going to be faster. -3/2. And last one, f of 1, plug 1 into my function. I get 11/6. So again, these are the only places the absolute max and min could happen. And now I know by plugging into the original function what the y values are. And so now I can answer what is my absolute max. My absolute max is the highest of these values I get out. Only one of them is positive, so my absolute maximum is 11/6. My absolute min is the lowest value I got out, and that's going to be negative 41 over 6. This is a general strategy for finding absolute extreme. It's called the candidates test, because you kind of list off candidates for where it's possible to happen, and then you plug them all into your original function to figure out which one's actually biggest and which one's actually lowest. And here's a strategy. Again, you can read this and write it all down, but it's basically what we just did. I find the candidates by finding your critical points and your endpoints, and then determining which one is the highest by plugging into the original function. So here's another example. I just want to figure out the absolute extrema of this function. So I'm going to make my list of candidates because it's called the candidates test. And I already have a couple candidates. I have -1 and 1. And now I want to figure out other candidates. So that's going to happen at my critical points. So I need to find my derivative. Make sure every time you do a derivative, you ask yourself real quick, are there any derivative rules I need to do? I see this pair of parentheses, which means I need to do the chain rule. So the outside 3 first, and the inside next. This again, it's kind of complicated polynomial, but it's still just a bunch of powers of x and coefficients and things being multiplied together. So this is never gonna not exist. So I just need to figure out when this is 0. And that's gonna happen when the factors are 0. So I get plus or minus 1 again. All right, I don't need to add those to the candidates list because those are already in the candidates list. And I also get 1/2. So I have 3 separate candidates that I can plug into my original function. Again, this is the hardest part about the candidates test right after we did increasing and decreasing. Is now that you find these values, you don't plug them into the derivative. You're putting them into the original function because I know what's the original highest and original lowest value. So -1 is going to give me -1 squared is +1 is 0. 0. 1/2 minus 1/2 is -1/2 cubed is -1/8. All right. So what is my absolute max going to be? It's the highest value I got. I actually got it twice. It's fine if your absolute max happens twice, but there's only going to be one answer, and that one answer is 0. And my absolute min is -1/8. It's the lowest value I got from my possible candidates. All right, so here's one for you to try on your own. I find the absolute extrema of this function. I'll show you the answer in 3, 2, 1. The final line I got was the absolute max happens or is equal to 1. It actually happens at 1. And the absolute min is -7. It happens at x equals 3. So the candidates, these first 2 candidates just come from the endpoints. The other one, set my derivative equal to 0. And this is my other candidate for the candidates test. Plug them all into the original and lowest value, highest value. All right, so absolute extrema can happen at critical points or the endpoints. All right, the endpoints part is thing that people forget when they're doing these examples. And then once you have your candidates, remember you plug them into the original function.